This is week 12, lecture number 3. We will be focusing on sediment and its transportation in this lecture. So, as the course content here in 12, we are at 3. So, sediments. So, what are the sediments? Basically, the sediments, any sediment which has a source, like it eroded and then transported to or deposited by flowing water. So, water is basically the driving force to displace the sediment from one place to another place, and this they're responsible for transporting a significant proportion of many nutrients and contaminants. So, since the sediments which has both solid as well as mineral part, so the mineral part that means it is a nutrients. So, when that sediment is transporting, that means the nutrients also will be transported along with the sediments. So, and so basically the sediments comprise of a mineral component which is arising from the erosion or bedrock. So, if you see this, so this is during weathering, what happened, these small rock fragments are going to break down, and then it is going to divide into solid as well as mineral fractions. And the other one is organic component which is arising during soil formation processes. So, because the soil has inbuilt microbes as well as any dead animals on the plant material. So, anything which will be packed by soil and over a period of time, so that will be converted into that will be decomposed into organic material. So, that is why the soil also contains the organic compounds along with the mineral as well as the solids. So, then so the next is the sedimentation process. So, the sedimentation process basically, so first thing is the erosion, then transportation, the other third process is the deposition. So, the erosion is basically the wearing away of the earth's surface by surface water runoff. So, once the defragmented particles which are staying on nearby areas, so because of the rainfall or any other the flooding flooded flows, so the loose particles will be transported from one place to another place. So, that is the transportation, the movement of eroded particles through stream channels to the point of deposition. So, here mostly, so due to the rain, so this kind of a flash erosion. So, it takes away the particles along with the flow, then the transportation of particles, because the flow will have enough transport capacity and they will take away the particles from one place to another place, but due to the capacity of the flow, or maybe due to the infiltration, right, and then or if there is some depression where the sediment is going to trap down. So, then the flow capacity is not going to be enough to transport the particles, and there is a deposition of the particles are going to take place at the at some place. So, it consists of both erosion to acquire or to result the particles, and then transportation to displace the particles, and the deposition to deposit the particles. So, deposition of eroded particles in the stream channels, floodplains, reservoirs, canals, etc., where there is not enough the flow, where the flow has not enough transport capacity to carry out. So, and then the sources of sediment, basically one is the land clearing. So, there is a direct relationship between the increased erosion and the sedimentation. So, once the erosion is increasing, definitely the sedimentation will increase. So, land clearing in areas where catchments have been cleared because it has deposition of sediments, and the river banks and consistently grazed sediment loads are often high. So, when the river banks are grazed, what happened, the vegetation which is intact with soil will be loosened off. So, then once the soil is loosened, So, the definitely when the rainfall definitely the runoff due to rainfall will take over the loose sediments, and that so the land clearing will be the source of sediments. And the grazing along river banks can strip vegetation, disturb the soil and banks. Of course, higher flows increase erosion of the stream channel, leading to creation of deep gullies. So, when the flow is tremendous, so what happens, it definitely will result in eroding the stream banks and taking away the bed load. So, all of the things are going to happen and forms finally the gullies. Okay, so, the land clearing is one of the sources, and the road building. So, nowadays if you see the construction of the roads or construction of houses leave lot of sediments out at the site, and when there is a rainfall, so definitely the particles or the sand or any building material that will be transported to the the drainage ditches. So, the unsealed roads can contribute to significant sediment loads. Of course, so unsealed, which is exposed to water, definitely will erode, and the compacted road surfaces are subjected to erosion, which generate the sediment. So, unsealed and compacted. So, without putting any the impermeable layer. So, definitely a simple compaction definitely may not helpful in protecting the sand, protecting the sedimentation. So, the points where roads cross streams are particularly damaged. So, if you see during flooding, the roads which are across the stream flow definitely going to damage first, and the roads can become long term sources of sediment if they are not properly maintained. So, this is the regular practice. If you see in summer season, all roads will be laid off, like the maintained very well, and then the next rainy season, because of the poor maintenance, so the roads will be damaged due to the heavy rain and the flooding, and that definitely causes the removing the concrete material or removing the fine particles from the roadside. And then the in-stream disturbances, this is another source of sediment, in-stream disturbances. So, when the dams and reservoirs are under construction, so disturbances to the stream bank can generate large quantity of sediment. So, in under quiescent condition, you may not be seeing sedimentation transport to the downstream, but while constructing the dams or while doing any in-stream operations, definitely that disturbs the bed sediments, and definitely that causes the and because the flow. So, the disturbed sediments will pass from one place to another place. So, other activities like mining. So, the mining is another terrible event in removing the sediments, and dredging, this is another operation. Some industrial processes, so like which contains like sediment using dirty, for example, waste treatment plants, all those things, and cleaning weirs and other field deposit sediments. So, ware cleaning also, because ware has lot of deposits. So, once you clear that, then definitely that will be mixed in the water and causes sediment transportation in that. So, the classification of sediments, we are talking about the river. So, the classification basically the deposited sediments and suspended sediments. So, deposited sediments also known as the bed load, and it definitely will be staying here in the bed, and the suspended sediments will be staying here. So, mostly the suspended sediments will be suspended in the water. So, is found in water column where it is being transported by water movement. So, mostly the suspended sediment will be transported from one place to another place, whereas bed deposited sediment, unless there is a the heavier flow which can take away or which can affect the bottom of the river. So, the bed load will be staying in place. So, and then suspended sediments. So, basically the suspended, it contains suspended matter. It is also called as particulate matter or suspended solid. So, it has different names: suspended matter, particulate matter, and suspended solids. Okay. Suspended solids refers to both mineral as well as organic solids. So, since it is dissolved or suspended inside, so the mineral portion as well as organic solids will also attach to the suspended solids. That is why the suspended solids refers to both mineral as well as organic solids. So, then sorry. So, if you the types of theory of sediment transportation, if you see, so basically it is a contact load that is mineral that rolls or slides along the bed stream. So, this is called contact load, contact to the surface, and suspended load. This is also another type of suspended load, the material that moves along the stream in suspension, just I mentioned, and saltation load. So, this saltation load is the bouncing, some particles or some solid or eroded particles, they bounce. So, just like here, so they simply bounce from one place to another place. That is called, and the stream bed contact with the bouncing particles, which may force other particles upwards in short period of time. So, once if there is a particle here and this particle comes and bounces here and impacts, and this goes up for short period of time. So, that is the saltation. So, the bed load, which is equal to the coarse material moving near the bed, right. So, the contact load and saltation load and other particles that cannot be sampled by suspended load sampler. This is also, so the coarse material which is not sampled by suspension or suspended device, suspended sediments, that is called bed load. So, the bed load contains both contact load and saltation load. And then the next is the sediment transport. So, basically the direct function of water movement. So, if you increase the water movement, definitely the sediment transport will increase. So, during transport in water body, the sediment particles become separated into three categories. So, suspended material, that which includes silt, sand, clay, and coarser material. So, relatively inactive bed load, and then saltation load. Okay. So, the suspended load, the sediment particles basically of three kinds. One is sand, silt, clay, mostly this will be under suspension, and little coarser particles, they will be inactive, the bed load. So, they will be staying nearer to the bed, and saltation load. So, they will be bouncing and rolling is taking place here. So, the suspended load basically comprises of, as I said, sand, silt, clay size particles. So, this all suspended in water, right, and then it divided into wash load, which is generally considered to be silt, clay sized particle, which is less than 62 micron or 60 micron in particle diameter. The wash load is mainly controlled by supply of this material. So, basically the wash load is suspended load, which contains mostly the particle size which is less than 62 microns. So, that means if you do sieve analysis, so the last, like if you have like 62 microns sieve at the bottom, so the pan which collects the sediments, that is called suspended load, whatever it may. And the amount of sand which is, if suppose more than 62 microns, so that is called sand in the suspended load, directly proportional to the turbulence, and mainly originates from erosion of the bed load and banks of the river. So, mostly the coarser particles which are not part of the suspension. So, that means more than 62 microns will be depositing here as the coarser particles and staying in the bed of the river. So, The mineral fraction forms most of the transported load. So the mineral fraction of suspended load will be mostly transported from one place to another place. Okay. And then the bed load. So the bed load is a stony material such as gravel and cobbles, moves by rolling along the bed of the river. So if you see this, mostly all these things are bigger particles, and they bounce. That's I mean, the bouncing is the saltation, and also the roll from one place to another place. So too heavy to be lifted by suspension by current of the water, current of the river. Important during the period of extremely high discharge in the landscapes of the large topographic relief. So if you have steep slopes and you have higher flow rates, definitely the bed load is going to move, or there is a importance of bed load. So rarely important in low lying areas. So this we even in hydrology we will be not focusing on bed load, but rather the sediment I mean suspended load is more important. So then saltation load. So the saltation means the bouncing, as I mentioned before. So it refers to, so it basically refers to particles that are light enough to be picked off the river bed by turbulence, but too heavy to remain in suspension and therefore sink back to the river bed. So what happens? So the turbulence, is I mean causing, but it's heavier to lift. So that's the reason it will be staying in the ground, staying on the ground, and just moves, just rolls. So the transition between bed load and suspended load. So this is in between bed load and suspended load. So suppose if there is too much turbulence, this will be lifted up, but because of heaviness, so it will again come down. So never measured in hydrology, this thing. So the problems due to sedimentation. So reservoirs, if you see, so loss of potential water storage, because when there is a deposition here, so definitely the capacity of water will be reduced. So only this is the capacity now compared to the actual capacity. Okay. So that's so definitely loss of potential water storage, and storage reduction due to increase in evaporation. Not only that, because now it is a shallow, right. So this is a sediment deposition. Now it is shallow and it is easier to evaporate. Okay. If it is shallow, and then and it is easier to heat it up and then evaporate. So evaporation will be more. And irrigation canals are scour and sediment deposition can occur due to erodible construction of materials. So if you construct irrigation related structures, right. So definitely that will scour and deposit the sediments in the irrigation canals. So again the canal capacity will be reduced, and degradation below dams. So potential dam failure definitely influence the quality of water downstream the dam, and its low lying bed stream level. And power station turbines, sediment can damage the blades and bearings. So when you compare with the clean water versus the water with sediments, so definitely that scour the blade of an impeller or blade of and also the bearings of the turbines. So because the turbines are intact with water which is coming in. So then in rivers, the sediment transport in rivers is associated with a wide variety of environmental and engineering issues. So if you see here this river, so it has a lot of rivulets. If you see here, so it's supposed to be a single river, but because of the sedimentation, so the river, the capacities or width, effective width is being reduced, and the depth of river is going to be reduced, and definitely if there is a large flows and there is a chance of flooding nearby areas. Okay. One of the most serious environmental problems is erosion and the consequent loss of topsoil. The rate of soil loss is generally or greatly increased by poor agricultural practices. So, nearby areas, if there is a poor agricultural practices and lot of tillage is taking place, so definitely that will influence the water quality of the runoff water which is taken from the agricultural fields to the rivers. And soil loss and so the solutions, if you see, so the loss of topsoil results in economic loss to the farmers, of course, because the topsoil is fertile soil, and once the topsoil is been removed from the fields, eroded from the fields, definitely the fertility of the land will be decreased, and that affects the crop yield, the equivalent to hundreds of millions of US dollars annually. So, that is because of loss of soil productivity, and the good environmental practice in agriculture like contour and terracing in the steepy land forms, and protects against soil loss. So, if you have some measurements or the conservation measures against this erosion controls, so that really protects the soil loss and protects against contamination of surface waters. The land use and land management, this has an impact on water quality. So, issues in sediment. So, here this table will definitely show some in the column number 1 sediment size. So, you have silts and clays and sand and gravel if these sediments. So, environmental issues with silts and clays, definitely erosion, especially loss of topsoil in agriculture and gullies. So, and sand basically in the river bed and bank erosion. So, river channel deposition, navigation problems and instability of river cross sections. So, cross section may be not stable if it is a sand, and the gravels channel instability when dredged for aggregates, instability of river channel beds, so problem in navigation and flood control. So, similarly, if you can go through this table for different sediment types, and the environmental issues can be caused due to particular sediment type, and associated engineering issues also can be seen in column number 3. So, with this the lecture number 3 on sediment transportation. So, the basically in the river, so 3 processes, one is erosion. So, the first thing is the because of the rain event or any soil disturbances. So, the particles will be loosened off, then and then if there is enough stream flow or runoff from the surfaces. So, that will carry the particles, and it has since it has enough transport capacity. So, it will carry further along, and when there is not enough transport capacity of that particular sediment load, and the sediments are going to be deposited there, right. So, here erosion, transportation, deposition. So, these 3 processes are important here, and there are a lot of issues, there are several sources of sediments and the problems which are causing due to sediments, and then how to tackle this sediment load in the rivers as well as the banks, right, as well as in agricultural fields. Okay. So, thank you so much.